All right, good afternoon, everyone, or good day, everyone. How are you all doing? My name is EMI-BRAIN. Today, we shall be looking at continuity of a function. In our previous class, we discussed extensively on limit of a function. In fact, we started by talking about types of function, what function represents, and we looked at the various types of functions. We looked at the one-to-one function, the onto function, the inverse function, the constant function, and we were able to identify what a function is. So I'll be posting the videos of the previous class. You can always search for them and update yourself, okay? All right. So I want us to look extensively on continuity of a function. Continuity of a function. Now, what does it mean for a function to be continuous? A function is said to be continuous at a certain point x equals to a on that function if the function satisfies three cardinal conditions. I repeat again, a function is said to be continuous at a certain point x equals to a if that function satisfies three conditions. Now, the first condition is that f of a is defined. F of a is defined. The function of a must be defined. Number two is that the limit of f of x as x approaches a must exist. The third is that the limit of f of x as x approaches a must be equal to f of a. Now, this is what I have on the board here. The condition for continuity of a function is that f of a is defined. Number two is that limit of f of x as x approaches a must exist. What does it mean for this to exist on that function? This simply implies that the limit of f of x as x approaches a on the left hand side must be equal to the limit of f of x as x approaches a on the right hand side. Now, the third condition, we say there are three conditions for continuity of a function. The third is that number one and number two must be equal, meaning that our f of a must be equal to the limit of f of x as x approaches a. Number one says f of a is defined. Number two, limit of f of x as x approaches a exists. What does this mean for this to exist? For this to exist simply means that the limit of f of x as x approaches a on the left hand side must be equal to that on the right hand side, must be equal. Now, the third condition is that f of a must be equal to the limit of f of x. This f of a must be equal to this. So if these three conditions are satisfied on the particular function given, that means that function is continuous at that point that was given. All right. Now, if any of these conditions actually fails, that means the function is discontinuous. So we can actually have a discontinuous function. Okay. So here we have types of continuous function. We have what called the pointwise continuous function. The pointwise continuous function, or pointwise continuity of a function. Pointwise is just a function is continuous. It's just like when a function rather is continuous at a certain point, s is equal to a. It's called pointwise continuous. But when a function is continuous at a range of value, it's called continuity on an interval. We have two types. We have the pointwise continuous of a function. We have the continuity on an interval, meaning if we are given a range of intervals, maybe -2, -1, 0, 1, and 2. And this range of intervals, okay, the function is continuous within this range of intervals of x. That means that we have a continuity on an interval, right? But if we are just given a certain value of x, let's say x equals to 2, or equals to 1, or 5, or 0, or 1, or anything, or -4, -1, that means that we have a pointwise continuity of a function. Now, let's look at a good example of a function, and let's determine if this function is continuous or not. All right, guys, so we are giving a good example here to solve. Given f of x equals x squared plus 1 and 7 minus x. For this function, when x is greater than or equals to 2, we are given this. It means that when x is greater than or equals to 2, the function behaves in this form. When x is less than 2, the function behaves in this form. Don't forget, if you are given a function of this kind, that x is greater than 2, that means that the value of x greater than 2 actually start from 2, the next will be 3, 4, 5, 6, right? But the question emphasizes that is this function continuous at x equals to 2? Because a function can be continuous at a certain point and not continuous at the next preceding point, right? Okay, but we are told if this function is continuous at x equals to 2. Now, don't forget that I gave us three conditions for a function to be continuous, and I will emphasize on the third because the third summarizes everything. Don't forget that we say that For a function to be continuous, f of a must be equal to the limit of f of x as s approaches what a. F of a must be equal to this. This must exist. This must be defined, rather. This must be defined. Then the limit of f of x as s approaches a must exist. So once these two are equal to each other, that simply means that the function is continuous at that point. So the solution to this, we're going to find first, the first condition is f of a is defined. Here, our a represents 2 because we are told is this function continuous at s equals to 2. So that will give us, if you look at this equation here, we have what we call a pointwise continuity of a function is a pointwise one because we are given at a certain value of x equals to 2. Okay, yeah, f is equal to 2, but we are asked to find f of 2. Let's define f of 2. Let's see if f of 2 is defined. Now I'm going to ask a question between this and this. Which of these functions behave when s equals to 2? When s equals to 2, the function behaves as s squared plus 1 because we are told that if s is greater than or equals to 2, that means the value of s in this function must start from 2, 3, 4, 5. But for this, s is less than, meaning from 1, 0, just that way, right? Okay, so for this, since s is greater than or equal to 2, so that means 2 is included in the values for x. So that simply means that I'm going to use s squared plus 1 to define f of 2. And that will give us what? 2 squared plus 1, that will be equals to 5. Now we have defined f of 2. The second is to check if the limit of f of x as s approaches what? 2 on the left hand side. We're going to look for the left hand side, then look for the right hand side. Then when both of them are actually equal, that means the limit of f of x as s approaches a exists, right? Okay. Limit of f of x as s approaches 2 minus simply means on the left hand side. When you hear the word left hand side, the word left hand side simply means that x is less than. The word right hand side means what? X is greater than. So which of these two functions behave in this manner? X is less than. For left hand side, we're going to use 7 minus x because here we are told that when x is less than what? 2, the function behaves as 7 minus x. So definitely we're going to make use of 7 minus x, and that will give us 7 minus 2. And we're going to have what? 5. So if we subtract these two, our answer becomes 5. Now let's look at the limit. The limit of f of x as x approaches 2 on the right hand side. I say the right hand side talks about when x is greater than, right? So which of these functions behave in that manner? Not the first function behave in that manner because in this function s is greater than 2. So it means that we're going to use our s squared plus 1, and that will give us 2 squared plus 1. And I think this should be equal to 5. Wow. Now what do you notice here? The limit of the function as s approaches 2 on the left hand side is the same as the limit of the function as s approaches 2 on the right hand side. That simply means that the limit of the function as s approaches 2 exists. So we'll say since the limit of f of x as s approaches 2 on the left hand side equals the limit of f of x as s approaches 2 on the right hand side, okay, is equal to what? 5. Therefore, the limit of f of x as x approaches 2 exists. So since this exists, the third condition for continuity of a function is that f of 2 must be equal to the limit of f of x as s approaches 2. If you look at this, wow, I think they are equal because f of 2 is 5, then the limit is also 5, right? So since the f of 2 and the limit of the function of x as s approaches 2 are equal, that means the function is continuous at s equals to 2. But let me put it down in statement. They will say since f of 2 is equal to the limit of f of x as s approaches 2. Therefore, the function functions are continuous at x equals to 2. Wow. Now let's look at another example on this, then we'll proceed to more complex example. All right, guys, so let's see example 2. The second example here, we are giving our f of x, and we are giving the various functions. Here we have 2x plus 5, x squared plus 2, and we have 5. Then this is the point of x. Here we are told that x is less than minus 1. For this, the function behaves like this. When x is greater than minus 1, the function behaves like this. Then when x is equal to minus 1, the function is equal to what? 5. Okay, so we are now asked, is this function continuous at x equals to minus 1? Okay, now let's move on. Now what are we going to do here is to define f of minus 1, right? Okay, let's define f of minus 1. The f of minus 1 is defined as 5 from this function, all right? From these functions here, the f of minus 1 is defined as 5. So that means this is the answer to this. Okay, the second part is to find the limit of f of x as x approaches minus 1 on the left hand side. And this will be, now let's look at our values here. On the left hand side, like I say, it simply means x is less than. The left hand side simply means x is less than. So which of these is telling us x is less than? Is simply 2x plus 5. So this will give us 2x plus 5, right? So, and that will give us what? 2 minus 1 plus 5. The answer here should be 3. Minus 1 times 2 is minus 2. Minus 2 plus 5 is 3. So let's look at the limits of f of x as x approaches minus 1 on the right hand side. On the right hand side is simply when x is greater than minus 1, right? So that means that we're going to use this behavior, right, to find the right hand side of this limit. So that will give us x squared plus 2. And we are going to have here minus 1 all squared plus 2, right? And this will give us a value of 3. All right, guys. So what you notice, the limit of f of x actually exists because the limit of f of x as x approaches minus 1 on the left hand side is equal to that on the right hand side. So since these two are equal, that means the limit exists. So I'm going to start by saying that since the limits of f of x as x approaches minus 1 on the left hand side is equal to the limit of f of x as x approaches minus 1 on the right hand side, which is equal to what? 3. Therefore, the limits of f of x as x approaches minus 1 exists. Now, if this exists, is the function continuous or discontinuous? The function is not continuous. The function is a discontinuous one because f of minus 1 is not equal to the limit of the function. I can say that since f of minus 1 is not equal to the limits of f of x as x approaches minus 1, the function is discontinuous. Is discontinuous at s equals to what? Minus 1. Let's see another wonderful example. Okay, guys, let's look at this, the third example, right? We are given this function, we are given the behavior of each of these functions. We are told out here when x is less than 2, this is what we have. When x is less than or equals to 2, but x is less than 3, we have x squared minus 2, okay? 2 in this function simply is being read as 2 is less than or equals to what? X less than 3. This simply means that x is greater than or equals to 2, but x is less than what? 3. Please don't forget. This is read as x greater than or equals to 2, okay? But the same x is less than what? 3. So for this, we have x is greater than or equals to 3. Now we are asked a question, is this function continuous at x equals to 2 and x equals to 3? Now how do we solve this? The same process. Let's look at the first, which is x is equal to what? To a equals to 2. For the first one, let's look at the value of x as 2, right? Okay, the first is to define f of what? 2. Let me remove this. F of 2. F of 2 is simply defined on which function? On this function, because here we are told that 2 is less than or equals to what x. This simply means that x is greater than or equals to 2. So since we have an equal sign, so the value of x equals to 2 can be captured in this range, right? So that means that we're going to have this to be our x squared minus what? Minus 2. And that will give us 2 squared minus 2. So we're going to have 4 minus 2 equals to 2. So the next, we have defined f of 2. Let's look at the limits of f of x as x approaches 2 on the left hand side. On the left hand side, I've already said, simply means x is less than, meaning on this other side. So here we have x is less than. So this is for x on the left hand side, simply means x is less than 2. So that means I'm going to use this function to define the limits of f of x as x approaches 2 on the left hand side. And we're going to have here to be square root of x plus 2. And that will give us square root of 2 plus 2. That will give us square root of 4 equals to 2. Now let's take the limits again of f of x as x approaches 2 on the right hand side. Right hand side simply means x is greater than. So in this case here, we're going to use the second function because here we have x is greater than or equals to 2. If we have a statement like this, I repeat again, this statement is being read as 2 is less than or equals to x. If 2 is less than or equals to x, that means that x is actually greater than or equals to 2. So that means greater than is here. So that means we're going to use this, which is x squared minus 2. And that will give us 2 all squared minus 2. We're going to have 4 minus 2 equals to 2. Wow. What do you notice here? The limit of f of x as x approaches 2 on the left hand side is the same on the right hand side. That means the limit exists. So since f of 2 is equal to this limit, the function is continuous at s equals to what? 2. So what do we do? Now say since the limit of f of x as s approaches 2 on the right hand side or on the left hand side is equal to the limit of f of x approaches 2 on the right hand side is equal to what? To 2. Therefore, our limit of f of x as s approaches 2 actually exists. It exists, all right? It means that if we are to approach x on the left hand side, then approach x on the right hand side, both on the left hand side and on the right hand side, and the limit is the same, that means that the limit exists. So if the limit exists and our f of a, which is f of 2, is defined, is equal to that limit, that simply means that the function is continuous at x equals to 2. All right, let me finish up this. So we have, since f of 2, which is defined, is equal to the limit of f of x as s approaches 2, therefore the function is continuous at x equals to 2. The function is continuous at x equals to 2. So let's look at the second example. The second one says, is this function continuous at s equals to 3? Is this function continuous at s equals to 3? You can pause the video, then try it out yourself, then tell me if the function is continuous at s equals to 3. Okay, let's look at this example. We are given f of x to be this. We want to see if this function is continuous at s equals to 3. Okay, the first thing is to define f of 3, right? F of 3 is defined on this equation because here x is greater than or equal to 3. So that means we're going to use 2s plus 5 to define f of 3. So that means that we have 2 times 3 plus 5, and this will give us 11 because 2 times 3 is 6. 6 plus 5 is 11, right? Okay. So let's find the limit of f of x as s approaches 3 on the left hand side. On the left hand side simply means when f is less than. Okay, this is f less than 3. So this function will be used for the limit of f of x on the left hand side when s approaches what? 3, right? Okay, so let's look at it. We have s squared minus 2. S squared minus 2. That will give us 3 all squared minus 2. Here we have 9 minus 2. The answer here is 7. Okay. Now let's look for the limits of f of x as s approaches 3 on the right hand side. On the right hand side simply means s is greater than. So here we have s is greater than. So that means we're going to use x plus 5 to solve for the limits of f of x as s approaches 3 on the right hand side. So that means we have 2 times 3 plus 5. This will give us 6 plus 5, which is equals to 11. Alright guys, so what do you notice here? The limit of f of x as s approaches 3 on the left hand side is not equal to that on the right hand side. That means the limit of the function as s approaches 3 does not exist. Okay, it does not exist. So we say since the limit of f of x as s approaches 3 on the left hand side is not equal to the limit of f of x as x approaches 3 on the right hand side, okay, it's not equal. Therefore, the limit of f of x as s approaches 3 does not exist. Okay, since this does not exist, that simply means that we have a discontinuous function. And since the limit of f of x as s approaches 3 does not exist, the function is discontinuous. At x equals to 3. It simply means the function is discontinuous at s equals to 3. Alright? Okay guys, ensure you subscribe to this YouTube channel and ensure you share to your friends in other schools and ensure you click on the bell to have access to more of our lectures. Alright? Thank you so much for staying throughout this class.